Today's lesson is about the distribution of the differences of two means. So we'll start out looking at the standard error for the differences of two means, look at the central limit theorem, and then we'll look at our t-distribution. So our standard error for one mean is just the square root of one of these fractions, where sigma is the standard deviation of the population of your first population, and then we got to square that over the sample size of that first population. But since we have two different means, we then got to add in basically the same thing for our second population. Standard deviation of that population squared over the sample size squared. And then once again, smaller or larger sample size will result in a smaller standard error. So when n is large enough, or not n, our sample size is large enough, then we'll end up with our distribution being normal. That's what this n in front means. And it will be centered around the differences in the two means with a standard error of what we have right here that we just looked at on the last screen. Basically, this becomes normal if both sample sizes are at least 30. So consider this situation. So let's take a look at our distribution. We know it's going to be centered at the differences in our two means. So our first mean is 534, our second mean is 500. So we need to subtract those two, and we'll get 34. Then we need to look at our standard error. So we need to take the standard deviation of our first sample and square it, divided by that sample size. And then we got to add the standard deviation of our second sample, square it, and divide it by our sample size. And put that all inside of a square root. And when we work that out here, we get 23. So it's going to be normally distributed, centered around 34 with a standard error of 23. So here's our standard error formula. But very rarely do we know the standard deviation of the population like we did in the last one with the SAT, where they actually collect data on everybody that takes it. So what do? We approximate that standard deviation of our population with S, the standard deviation of our sample. Well, when you do that, replacing your standard deviation of your population with the standard deviation of your sample, that changes our t-distribution to a t, or our test distribution to our t-distribution. Now, the degrees of freedom we had said was always one smaller than your sample size. Here, because we have two sample sizes, it's one smaller than your smallest sample size. Now, it ends up being essentially normal if both sample sizes are greater than 30. And once again, your degrees of freedom is always one smaller than your smallest sample size. So our test statistic would be the difference in our two means over the standard error, with the degrees of freedom of being n minus 1.